You're listening to Tech 5 Pittsburgh. It is your front row seat, all things around Pittsburgh's technology and innovation ecosystem. I'm your host, Jonathan Kersting with the Pittsburgh Technology Council, where I have been telling the story of Pittsburgh's tech companies, the men and women behind them, for nearly 30 years now. Can technology transform a building from a static structure into a living, breathing entity that adapts and learns? In a world where workplace efficiency and sustainability are critical, discover how cutting-edge design technologies are revolutionizing how we create and interact with our built environments. For today's show, I'm welcoming Jeffrey Murray and Christopher Whitcomb of CannonDesign, so you can learn how digital twins can predict and optimize building performance before construction. You can understand how smart building technologies can dramatically reduce operational costs. And finally, we're going to explore how innovative design can enhance human productivity and well-being. Listen now to uncover how CannonDesign is using AI and advanced technologies to create spaces that don't just work, but actually improve how we work. So let's start nerding out right now, and let's welcome Jeffrey and Christopher to the show today. So much fun having you guys hanging out with me here today. Of course, in our Huntington Bank studios, where I have the best conversations with our member companies here at the Pittsburgh Tech Council. And I'm just a huge fan of what Cannon does, because I think it's often underappreciated just how important our spaces are. It's kind of one of those things where you know when you got a good space and you know when you got a bad space. Sometimes we're not always thinking about what that really means to us as human beings, having to be productive, creative, and efficient, and all that kind of good stuff. So I'm glad to have you guys here today. So I love starting with introductions, so our listeners who's who and what's what and all that kind of great stuff. So Jeffrey, let's start with you and obviously what you do with Cannon and your background real quick.
Yeah, so I'm a boomeranger, Pittsburgher. I grew up here in Penn Hills. Left for 30 years, going to school, working all over the country. I'm a principal with CannonDesign. I've been back here in Pittsburgh 20 years, so
Excellent.
I think I've seen really a great transformation of the city. I've been in LA, DC, Chicago, Dallas, lots of places. I love Pittsburgh best. It's great. It's a great town. It's getting better, and I'm excited to be here. So as a principal with CannonDesign, I really lead the market for science and technology in our region. We call this the Great Lakes region.
Yep.
And that means all the buildings we design that support science, scientific research, advanced technology use in buildings, things like that.
You're at the cool intersection of leading edge tech and building spaces. And that's why we love these conversations, because we just explore how technology infiltrates everything. We're going to be nerding out on that. Before we do that, Chris, come on, man. What's up with you here today?
Yeah, Chris, Jahn. I'm also with CannonDesign only for about 2 years.
Okay.
And my background is architecture, principally for really techie spaces where innovation happens, right? Much of that for higher education. But really what it comes down to is I am such a nerd deep down inside. And when I get to design the spaces where other nerds can really do their craft, it's really gratifying.
Cool.
So
You're like a nerd's nerd of architects.
I am. I'm a nerd's nerd. Thank you. Yeah. And I grew up in a small town in Illinois, practiced for a while in St. Louis, and then came back up to Western New York and Rochester. So like coming to Pittsburgh with Cannon, these gritty cities that I've been a part of for my entire career, Pittsburgh is just the best.
It's something special about it. I really think
there's a certain moxie about Pittsburgh, and you can feel that, especially when you're in these towns that they aren't the Chicagos and New Yorks of the world. There's something really edgy, something really genuine about these towns. And I think that plays well into the creative nature of all of the crazy tech that's going on here with robotics and nuclear and all these crazy things that we're reading about and designing for.
Oh, absolutely. About Pittsburghers, you don't have as much 3H drywall here as you do in most cities, which is pretty I like it. Especially when you talk about the idea that you're building tech spaces. You're a tech nerd, as you say, but you're building spaces that are efficient for technology. And I look at how over the years that I've been covering tech, how so many tech companies really identify with their spaces, right? Because they understand the importance of technology and innovation and design. They want to live and breathe that. So you're in a great space here to design spaces for our tech companies. And of course, you design them across the country and around the world, which I think is really interesting stuff. And in today's conversation, we're just looking at that intersection of some key technologies that are just really just transforming how spaces are being built and designed, right? Really cool stuff. And especially when you talk about things like digital twins and things like that, where you can actually have like a building that doesn't really exist, but it exists in the digital space, and you can actually model it and you can see what it's going to need and not need. It's just, whoa, we can have a lot of fun today, guys. I'm excited about the conversation. So I'm going to put my seatbelt on because we're going to have some fun.
Sounds great.
Exactly. So what's the best way for us to like kick this thing off? Can we talk about some of the key emerging technologies, and then maybe we pick those off and just start diving into them a little bit? I talked about digital twins. Is that a good place to start?
Yeah, sure. The digital twin is basically a virtual building. It's meant to be exactly a virtual element of the building that matches what the real building is. And most digital twins right now are being used in building operations and things like that. So after you build a building, in fact, the guys we're working with right now, boy, I hope I can say this, they're doing a digital twin of falling water, which is like really cool.
Is that part of the restoration they're doing there? Some of that work?
It is not part of the restoration, but it's part of the ongoing work of managing and operating the building and falling water, making it efficient. One of the things that happens with falling water is it gets really hot in the summer. And I've been involved in computational fluid dynamics studies where we learned that at the top of the stair, there's a secret little window. And if you open that window in falling water, it cools the whole upstairs off.
No way.
And the new executive director didn't know that. I saw him I was having drinks with them back in December. And so I sent him some of this information, and now he's working with our digital twin partner to build a digital twin of falling water so they can understand airflows and all those kind of things. But so
that might actually be cooler than the Lego set of that, which I've yet to procure. That's one of the first like architecture series thing they came out with. I'm like, I have to have that. I just got on record and saying it, but the fact that there is such an impressive landmark like falling water, and it's going to embrace this type of technology, that's awesome.
Yeah,
just gonna say.
So one of the things we're doing with it now is we're trying to look at how can this digital twin technology really work during our part of the project, because when you're making a building, we design it early on. And so much of our design is based on what I would call expert intuitions, right? We have our intuitions about what works and what.
Your experience is doing so many projects where you know what works in certain situations and so forth.
That's right. Yeah. But a lot of it is, we tell a client, this is going to work. And then we go, is this going to work? But so we're looking at.
It'll sure look good though.
We're looking at these digital twins. And now we're doing a thing where we're actually working with NVIDIA, and we're working with this digital twin developer on a public health laboratory we're doing to understand the flows and the movements, because it's a very complex 300,000 square foot laboratory. It's under construction now. But the key thing is how quickly can a sample coming in of Ryzen or some very toxic thing, how quickly can it get into a containment area and move through the lab and that? So we're trying to develop these digital twins and study how we can model and simulate those kind of movements and behaviors in a building, so we can know that our designs, our intuitive designs actually work, and we can prove it to our clients. We can say, look, see, if we do it this way, if we get rid of this stair, now all of a sudden we've increased the pathways for this nurse to get from here to here by 5 times. And so we really need this extra stair. We know the owner might not want to pay for this extra stair. We prove to them, hey, this stair can help make everybody's work more efficient.
And that makes it a building you want to come to work in, because you're not annoyed that you're walking an extra 5,000 steps a day because you're going from room to room and don't have a stairwell that could have been there. So I'm thinking, like, Chris, as the nerd you're talking about yourself, has to get you really going when you're seeing this type of technology.
It does. Taking it into that realm of having that digital virtual world inform the built environment in such a profound way. And it enables us, just like we're seeing in research right now, although the research environment has actually changed around the same technology, where researchers have digital twins of a human organ. It's on a microchip, and they can run experimentations in the computational realm, come up with a theory, test it in the laboratory, gather the data to refine the twin, and keep the cycle of innovation going at a much faster rate. And so that same type of idea translates to us in architecture.
Completely.
Our buildings last 50, 70, 100 years. And so by the time we get the feedback in a traditional model, it takes decades to really inform the trend.
It's generations to inform the trend. So I'm curious, as Jeffrey was mentioning that you can test your intuition and then really start seeing things, does this allow you then to come up with even maybe potentially 3 or 4 different ideas at the same time and then run them across, where maybe you wouldn't have the time to do that previously, but now you can really you can model out a bunch of different scenarios.
Yeah, rapidly ideating on all of this. That's informing how we educate our architects coming out of school and really informing our design process, because we can test these things out in ways we never could before. And ultimately, we get to a much better outcome.
Yeah, and the tools are powerful because it was Thomas Edison who said, if you want to get a great idea, begin with many. And we embraced that ethos. We always had, even before we had this technology, we always looked at generating lots of options, because it's much easier for a client to make a decision when they're looking at 2 or 3 or 5 or 10 things than trying to decide whether they like one thing or not.
That's a great point. And they can see it in action too, right? The whole idea, you can see if that stairwell's not there, you can actually see how the movement's going to go around it. And
that's where the 3D modeling and the computational dynamics are so great. But we do have algorithmic tools and other ways of generating thousands of options right away, just with AI and with computers, so that we can generate all these options. Then we can go through and start sorting out which ones might make sense to present to a client in a work session.
I think back 20 years, and I think maybe it's a little longer, correct me if I'm wrong, but the idea that like CAD was this cool thing, so you could design stuff in CAD and you have these designs. But I feel like maybe in the past 10 years, maybe even less than that, where we have these technologies where you're just using high horsepower technology here to just take designs to whole other levels and quickly. That's got to be such a crazy wave to be riding when you're in this industry, right?
It is, and it's so necessary. Buildings are way more complex than they ever used to be. So
imagine.
Think about 100 years ago. For ventilation, you open a window. For heat, you got a radiator. Air conditioning, data, forget it, right? Now we have all these systems in our buildings, and we have to figure out ahead of time, how are we going to make this all fit? How is this all going to work? And so the traditional hand drawing, the blueprints, right?
Doesn't work anymore.
It absolutely does not work anymore. It's a tool that really enables us to leverage the technologies that are available to us now that make our buildings healthier, smarter, use less energy. Without these tools on the design side, we could never achieve those outcomes in the built world.
So I'm assuming not only can you come up with more designs and more iterations and be faster, that's all going to really start impacting that you can do things at a better cost as well too. So you can bring really advanced stuff at a price point that becomes, whoa, we can really nerd out on this, for lack of a better term. I don't know.
Costs are a challenge.
They always a challenge, of course.
And again, one of the things is buildings were simple. I like to say a conventional office building today is more complicated than the Gothic cathedral, even if a Gothic cathedral looks a lot more complicated. But all these systems cost a lot of money. And Chris and I are working together on this public health lab in West Virginia. It's a really cool project.
Where in West Virginia is this?
Down in South Charleston.
Okay. Yeah. Very cool.
And it's a really cool project, and the budgets are tight, and they're getting tighter now with what's going on with the price of steel and aluminum and things like that. So we're worried about the costs. Yeah, we won't go there, but yes, they're going up. We'll just say that. But we have our in-house, we have our own cost estimating group who, again, have really cool advanced tools that they're using to do cost modeling and understand where, and this is part of the way we design. We used to design in a way that we would design something and then price it and see where we were. Now we know that doesn't work. That's just
that makes sense.
Inefficient. We try to set target prices for every building system. This is how much money we have for the building envelope, the skin, the aesthetics of the building. On the outside, this is what we have for the mechanical systems. This is what we have for electrical. Then we all go back and try to design to those targets. And again, I don't think we could do that without the technologies that we have today, I think.
And where we really make a lot of headway too, let's not forget that the cost of constructing the building is the smallest cost in the entire life cycle.
Never thought about it. Is that really? Okay, yes. Yeah, I guess it's this one cost at one point, but then there's the lifespan.
It's a lot of money up front. And then the cost to operate it far outweighs that initial first cost.
Okay.
And then when you factor in the true cost of all the people that work in it, their salaries, how effective they are, how healthy they are, how often they show up for work.
That's getting pretty cool when you're looking at when you're taking the data that deep, that becomes pretty impactful.
Exactly. Wow. And when you parse that out, then some of these things that seem very expensive on the front end, you realize what a tremendous return on that investment there is.
Take it out 20 years, 25 years, or 10 years even, you could probably see, wait a second, okay, it's worth the money up front.
Right.
We work with a large international company who has a significant presence here. And we had started on our project, and the project grew in scale. People needed more stuff than they thought they needed. And all of a sudden, it was way out of budget. And the North American CEO said, I don't think we're going to be able to do this unless we can figure out some story. And what Chris said is exactly the story we told. We just said, if you look at the cost of the people over 10 years, and you understand then, if you can get this much 1%, we projected 1% performance improvement out of people, then the extra cost of this project will pay back in a year and a half.
Right. So you take one person who's making $100,000 a year, that 1% times 50 employees times, all of a sudden you're getting some real dollars.
You're getting real dollar saving. And this company was progressive enough. In fact, they went back and said, no, we're going to add some more to the budget because we think we can get 2% better improvement of our staff.
We might go 2.2 if we really optimize our numbers.
I was like, oh, that's way beyond me. I was just throwing numbers in the air.
That to me is just so interesting. The idea that we're talking about digital twins and analytics and algorithms when it comes to designing spaces and buildings, to me, is just so cool. One thing that I would love to talk about is the technology we're now seeing inside of buildings, right? That's mind-blowing in itself when you here's another set of algorithms and data points we're going to be collecting and stuff that keeps a building at the right temperature and everything like that. What is going on when it comes to tech inside buildings? I think that's got to be off the hook.
Go ahead, Chris.
Yeah, there's several different aspects of that. There's the obvious with the cost of energy and so much emphasis on energy, whether or not you're doing it for sustainability of the human race on the planet, or if you're just doing it more on the economic side.
Yeah.
There's nobody that's going to complain about spending less to heat and cool our buildings.
Of course. And real fast, is like the whole LEED certification thing still a big thing? I know for a while people really bragged about it, but I haven't heard as much lately. I don't know if it's just gotten quiet or what.
There are still some owners that are going to look for that, sure. It's part of policies. It's part of policy in New York State to design to a LEED Silver level. Okay. But there are other programs as well. There's the Green Globes. There's the
Living Building Challenge.
Okay. So people are still really careful and want to make sure that when they're building spaces that they're as efficient as possible.
Exactly.
Yeah. Okay. Cool.
Right.
Cool. I'm just curious because you brought that up. I'm thinking of stuff. Yeah, I used to always get these press releases. We have this gold certified building. We have this platinum certified, and it was like higher the levels. Awesome. But I haven't received them.
And part of that too is that as a policy and as a program really pushed the needle forward. And now the building codes have caught up with it.
Oh, okay. So it's no longer news that you're doing something that's silver because that's just what's expected of you, like in New York.
It has become expected. And again, there was some fluff and all that stuff. So now that we have the analytics that we have, and part of what we're doing with smart buildings, with this technology now, is we're able to much more effectively measure actually how much a building is consuming. So when we talk about how a building's carbon footprint, we look at it in two ways. One is the operational carbon, which everybody thinks about. How much does it take to condition, to heat, to operate, to run the equipment, to do the science or whatever you're doing in that building. Okay. But then the other piece of it is called the embodied carbon. And that's the carbon embedded in the materials,
the concrete, the steel,
the process, the cost of
energy
construction,
and the process and
everything.
Produce it. So even like a brick is made out of clay, right? It's made from the earth, but you have to fire that clay in a kiln. It takes a tremendous amount of energy.
You have to transport it to the site, like all the good stuff.
All of that.
Yeah. So we have a pretty significant analytical team in our company now that has full set of all these analytical models. They can do energy modeling, carbon modeling, all these different types of ways, looking at water use and things like that, so that we can look at what we call designed EUI, which is energy use intensity. So understanding that, like the laboratories that Chris and I work on, they're the most energy intensive buildings in the world.
Gotta be, absolutely.
So because laboratories have all these safety factors, you're blowing so much air through it, they're very expensive to operate. So it's interesting. So when we can do a 1% improvement in a really complex laboratory building,
big dollars,
it's way better for the global climate than maybe a 50% on a conventional building or a house.
Exactly.
Because they don't have nearly the carbon footprint that a science building has. So that's a big piece of our looking at the technology, is how do we monitor and improve building automation systems and all that stuff. There's two other major components to that. One is to look at how can a building better serve the people that's in it, right, with the technology. So how can, we have really much more advanced AV tools and things like that now. We can create these sort of integrated digital physical experiences. When you really think about it conceptually, a building has the potential to be an embodied AI, right? It doesn't move around, but it can
gather
feel the
information.
weather.
Yeah.
It can gather the information with sensors. It's already very common to do daylight capture on a building. So we have sensors, photo sensors that capture the daylight on a building and adjust the lighting down when we don't need it inside, and very subtle things like that.
So cool.
we
I
can
love
save
hearing
energy.
stuff like that. Yeah.
And learning the
That's
patterns of how humans use the building throughout the course of the day. I'm sure we've all walked into a big room where there's a big event planned, and if we're among the first people there, it's really cold. They got the room nice and cold before everybody showed up, but the buildings can learn to do that on its own.
It knows every Wednesday there's 50 extra people hanging out in this one room.
Exactly.
Well, it's precisely that. Yeah.
That's
right.
so amazing to me. And it goes to show you just how, like technology is just, it's pulling our bacon out of the fire. Sometimes when it comes to making spaces that the world can continue to evolve without us burning it down.
And if we screw this up, we create what we call malignant. Thank you, Chris.
Yeah, you can edit that. Right?
Malignant complexity, which is when we have so much of this technology in a building that it actually makes it impossible to operate the building. So it's so easy to crazy with that.
Yeah.
And back in the day when this first started, you had the Siemens and the Honeywells and the Johnson Controls all saying that they were the smart building folks, but none of them talked to each other. None of them gave their data to the building owner. They collected all the data themselves. And so they just sold these expensive service agreements to owners without actually providing value. And so that's where our company saw an opportunity. And CannonDesign is one of the first in the country that's really doubling down on, I think we're getting ready for an acquisition, but we're trying to double down on the technologists and people that can understand how to integrate all these different systems in a building with smart technologies and do it in a way that's not overly complex, that actually makes it easier to operate those buildings.
Yeah, so you can literally get lost in the complexity at a certain point in time where it just becomes, okay, enough. We have the doors open, people can walk in here, and it'll be okay. Too many sensors start going off. But that's really cool. I'm curious, like, any particular projects that you guys worked on that you can maybe talk to me a little bit more in depth about some of this stuff? I always love it when you work into pretty cool building. What was it with Johns Hopkins University? You got some tremendous clients, which I think are really cool.
The AIMD project is really interesting. And again, this is a tiny little project. We're doing really cool tiny projects for Pitt right now for really great principal investigators. But this little one for Johns Hopkins, it was about 2,300 square feet, a very small little lab in an old warehouse building.
Okay.
But what they wanted to do was to develop a laboratory that could operate itself. So it's actually called AIMD, which stands for AI for Material Design. So what's being seen in the defense industry and other industries is that the development of new materials takes too long and it's going too slow. So they want to develop this lab, and it has a bunch of conveyor belts and robotic arms and all this intelligence in it so that it will develop a new material, a new molecule. It will test it right there, all automatic.
So a building that's actually creating its own technology.
It creates its own material, right, on a little slide. The slide goes, it gets tested by an electron beam scanner, and then it gets tested by an X-ray machine. It gets shaken up, it gets done. It gathers all this, characterizes all the data, and then it learns from it, and then it tries another material, and then it tries another material. So it's going to, over time, if this thing works, and it's very experimental, and I like to say it's very cool and probably scary too, but if it works, and we're not sure whether they're actually going to get to where they achieved, that laboratory will generate new materials on its own without any human intervention.
That's crazy. Okay, like my mind is now blowing at this point. Wait a second. We're still talking about building in spaces, not spaces that are building stuff. So that's pretty cool.
Yeah.
Great example.
And we have so many cool scientists we work with that are doing groundbreaking work.
Yeah, the labs at Pitt, like these are scientists that are looking at light wavelengths at the sub-wavelength nanoscale and using new computational hardware that is in the quantum realm.
Okay. Yeah. I do that every day. So
yeah,
I understand.
But it's one of the
the iPhone 19, I think, will be quantum ready.
Yes. It's one of the things that's amazing about these labs we're working on at Pitt now, Chris, is that they're going in an old building. And this old building was built in the 30s.
Right.
The building envelope is all stone and it doesn't have any insulation. So to do these laboratories,
you like opening inside the building,
it's a
almost.
Box in a box.
It's almost like a box,
right.
because we have to have such tight temperature, humidity controls for these lasers to work properly.
Exactly.
And yet we're dealing with 100-year-old.
Well, I think about Pittsburgh. If you're building something out in the cathedral learning, it was built in the 1930s, and it's okay.
And that's not just Pittsburgh. That's
of course,
we did that in Baltimore. That's a clean. That laboratory, that AMD is a clean room. We had to again build a box inside a box in order to get it so the machines could all work.
That's really crazy. Oh my goodness! Every day is a different day for you guys when you show up.
That's why we love to do it.
I was gonna say there's always a cool project, and it's like pushing your skills to being like, how do we make this work? We'll put a digital twin together first and see what happens. Awesome stuff. My goodness. So obviously there's so much we could talk about when it comes to just technology driving everything that you guys are into. I'm assuming though, I mean, there's other parts of your business where you take some of this, it's like the skunk works almost, and it starts to trickle down into other aspects of what you guys do. If you're on easier projects than putting together a lab where lasers have to have the perfect temperature and humidity and so forth in order to operate. I'm just curious about that.
There's a lot to be learned when you look at a lab building, especially when you're looking at ROI for mechanical systems.
Yeah.
And so, a lot of those lessons learned, if we can make a laboratory that might turn over the air 15 times with 100% outdoor air just to keep the inhabitants safe, those technologies apply for energy recovery and things like that to more garden variety buildings as well. I think some of the technologies that we're using just to keep all of the information straight during this design process.
That's something I never thought about, is that you actually need special technologies just to manage the technologies that
and all the parameters that are coming in. So, we have objects that they start out as like little blobs. We call them chiclets because they look like little chiclets, but they're chiclets that you can stretch and bend, and they have a bunch of data embedded in them. And so when we start out with any user on a project, we're going to ask some basic questions like, what do you do in the space? What does the space need to do to serve whatever you're doing, be it science, be it business, whatever it is? And we're embedding this chiclet with the data. Then we're taking the chiclets and we're spreading them out in the model. And those chiclets then evolve into something that looks more like a building in the conventional sense of the word. But it's all the data is embedded. So as the team are coming in and engaging the project at different points in time, they can all extract that same data and get the information they need to do their part of the design.
And I like what you're saying about team, because I don't think people realize, and we have in the media this idea that so-and-so designed this building. I think making buildings is really the ultimate team sport.
It has to be a team sport. Yeah. I mean, with various specialties that all come together at the right time in order to make the thing come together.
That's something else you didn't have 100 years ago.
At all.
We have like a specialist handling low voltage technology and security and data and lighting and electrical. Just to get those parts of the building, we have 6-10 people sometimes just for that one little piece.
So I'm curious, what's your footprint here in Pittsburgh?
We're over 25 people here in Pittsburgh, and Pittsburgh's one of our smaller offices across the country. In Buffalo, we have a couple hundred. Buffalo's the founding office, so we have a couple hundred people there. Chicago's probably the biggest office. We have an office in Mumbai and Toronto. Just acquired a firm with offices in Seattle and Portland. So,
and all points in between.
I think what I find really interesting, obviously, and people may not know, is the fact that how broad Cannon is. So when you have these projects, you are pulling in experts from really around the world to flow in and make these projects happen from time to time.
We absolutely do. The lab in West Virginia is 300,000 square feet, and we've got 30 or 40 people working. We have 9 different offices involved, and we're bringing in the specialists with the exact expertise that's needed for that project to come together. We work in a virtual space most of the time, of course. But at the end of the day, we do enjoy coming together as a team. And that kind of leads us to a point that we really like to stress, is that all of this technology is wonderful, but it has to be serving the humans.
Thank you for bringing that up, because that is just so important. I think we often forget that, because just the bang wow factor of what you're doing. But at the end of the day, it's still the woman or the man behind the mouse that's clicking away, that's manipulating these tools to bring that human vision and that need together.
And not only that, but the people who are going to use the building in the end, that's who we designed for.
And people have to enjoy the space and use it and find it useful. So
I mean, it's one of the cool things. CannonDesign, like lots of firms out there talk about design and human-centered design and things like that. CannonDesign, we've put it down in writing. We have a thing called living centered design, our ethos. And it's basically our philosophy for what matters.
Yeah.
But our view is the whole idea of having these design skills and trying to impact and change the built environment around the world is to help people flourish. And I know that sounds really fuzzy and stuff, but that really guides us.
No, that makes sense. You need that fuzzier thing in order to sharpen the tech.
Yeah,
I think to a certain degree, because you are trying to, at the end of the day, when it comes down to everything we do here, it's about people in so many ways. And so when you're creating spaces, because people are going to be using them until you have that one place where, of course, the building's doing its own thing. And we don't care what color the walls are when the machine is. But that whole idea, though, is that, people have to be productive. They have to feel like human beings. And I think especially now, like in post-COVID world that we live in, people are really rethinking like what their spaces mean and how they're going to function and how people are going to be using them and getting the most out of them. Because I don't see people working less anytime soon. And I think we continue to blur our lines between work and personal life. So when we are in our offices, we don't want to take extra steps if we don't need to. And we want them to have really clean air and all that good stuff. And not too hot, not too cold.
And really all the soft, fuzzy stuff, the aesthetics really matter. There's so much interesting science going on now with what's called neuroaesthetics and trying to understand that aesthetic experiences actually make us healthier and help our well-being. It's not just having the fresh air, but it's actually having positive aesthetic experiences that can make a difference for us. So we're deeply involved in that. I just accepted the position as the chair of the Pittsburgh Architecture Foundation.
Okay.
And that's going to be one of our missions is, because what happens is we take our surroundings for granted. Nobody notices them. We take them, they're just there. There's a famous line that design is 99% invisible. We only notice it when it fails. But the reality is that just because we don't notice it doesn't mean it doesn't impact us. So the science is pointing out how much it impacts us in subconscious ways that we're not even aware of. So those kinds of things are deeply embedded into CannonDesign's philosophy. We just started an AI group in CannonDesign to understand how we use AI to help our design processes and engage in that.
Makes
and
sense.
there's a lot of new tools out there like Midjourney and things like that. But our committee's really focused on AI ethics. And what does that mean? So we're taking a really deep view. We believe in ethical aesthetics in that we're not designing for our own egos. We're designing for the people who are using the buildings and this kind of AI ethics. What does it mean to use this technology and how do we use it? There's got to be right ways and wrong ways to use this stuff. So how do we use it the right way?
It's a lot to handle. Isn't it crazy how AI has opened these crazy doors for something that we have to form communities to think about this because it's a thing and it's true. And how you embrace that and how you leverage it are going to make all the difference.
And the pace that all of the change is happening at makes it all the more difficult to stay out in front and be thinking about how do we apply this in an ethical way and how are we applying it?
Absolutely.
How are we applying our craft to what really matters and not making the fact that we can do something in tech because it's so cool. It's got to have a deeper purpose than that. At the end of the day, it's as Jeff said, these are buildings for people. And if we fail in our mission to create great spaces for these people to innovate and discover, then we really haven't succeeded at all.
Exactly. Wow. Crazy stuff. How much fun talking about this stuff.
We're lucky. We like what we do. It's not easy, but we like it.
Yeah, no, obviously the passion comes ringing through, which I think is just awesome because that's what we love at the Tech Council. And our members have the passion. It shows through in their work and it gives the results. And these are the types of things that are making Pittsburgh and the world better places to be. Simple as that. So guys, really, what a great conversation. Really encourage everyone to check out your website and so forth, just to see all the things that CannonDesign does. You guys do some amazing work. I'm glad you guys are here in Pittsburgh. It may not be the biggest office in Pittsburgh, but I would say it's the coolest.
It is really a cool office. Actually, we definitely punch above our weight here. A lot of great talent in the city. And we're always looking to recruit more talent here because there's a lot of great talent.
That's great. I know on your website and stuff there, you have all your open positions and things like that. And so if you want to nerd out with a lot of technology and to help design cool stuff, you got the background, check them out. Oh my goodness, Jeff, Chris, you guys, awesome. You guys are the best. Thanks for being part of it.
Thanks for
Jonathan.
having us.
Hey, in case you forgot, this is Jonathan Kersting, and my mind hurts right now because I had such a good time talking about this stuff. I tell you what, I'm getting like an education every time I interview our members. Thanks for listening, everybody.